Welcome to this edition of the ePathshala for learning statistics and learning R for doing data analysis. My name is Arindam Basu. I'm from the University of Canterbury at Christchurch, New Zealand. And I will take you through some of these interesting topics where you will learn how to use the software R for doing hands-on data analysis on a number of topics. There are quite a few topics lined up for this particular phase, and the first one that we're going to start with here today is about drawing graphs and graphical elements and charts in R. And and in this particular module, you're going to learn several things. That is, how to use R as a canvas for drawing graphs, how you can actually start drawing graphs from real-world data. We will read real-world data and then draw graphs out of this. And so to get started, please bring up your RStudio as you have done before and work with the examples that we follow. So soon you will start working through a recorded presentation, and then we will work more on this. We start with an introduction, and then we'll talk about some of the basic graphing principles. And then we shall get into a state of demonstration of many different graphical features that are present in R. And then we shall summarize the main learning points. We'll keep the objective here very simple and single-focused. We are going to introduce you to the concept of drawing graphs using R software. To start with, there are four major points that I'd like to highlight. First, R has excellent graphing options. Of the many different statistical programming environments that we have seen, and statistical data analysis software packages that are available in the market, R is quite outstanding and excellent because even as the very base package, that is, even if you do not install additional packages like the ggplot or lattice, you can still have excellent graphs and really good graphic displays. And one of the reasons why this is such a powerful element is because in R, you can fine-tune and fine-control many of the graphical parameters. For example, the title of the graph. For example, you can control the labeling of the x-axis, the labeling of the y-axis. You can add points to the graph. You can add parameters and layers onto the graph. So there are quite a few things that are important. We are first going to learn how to draw univariate graphs. That is, bar plot, histograms, and density plots on the top of them. Then we're going to learn how to draw scatter plots. These are continuous variables on x-axis and continuous variable on the y-axis. And then we shall learn how to use the par options that you can use to divide the canvas into zones in which you can put your graphical elements. Par is a very powerful graphical element. There are quite a few things that you can explore in par, and I would refer you to some of the better books and study materials and articles and resources that are available that you can learn. I have included a set of readings with this module. I would strongly encourage that you go to those modules and start those practices, because in those modules I've given you some references and a few codes which you can reproduce. So without much ado, let us start looking at the data that we're going to use here in order to draw the graphs. For this exercise, we are going to have a data set which we have scraped from the web. And this data set is about the trajectory, or kind of the year by year adjusted or age standardized incidence of breast cancer in women aged 45 to 85 years old in 16 countries, several, 15 or 16 countries. These are all developed countries between the years 1996 and 2007. And this data set came from the IARC, the International Agency for Research on Cancer Datasets, that are publicly available on the web. And the purpose of this graphing is to chart the data of the women's age standardized incidence rates along the time spectrum. Now, the other side of the story that needs to be told is this: that in about 2001, there was a significant change in the practices of using what is known as hormone replacement therapy, and we would like to examine whether that made a difference. So there are a set of graphs that we have put not only in this particular graphing exercises, but you will encounter them in other modules where we will be looking at the transitions that have taken place between 2002 and 2007. So let's first start reading the data. You can see that there is a library called LME4 that got loaded. This is a longitudinal data analysis library, which is quite popular, not really necessarily important for only graphing in this particular scenario, but there are some other important issues. And then we're going to load the data that we shall be using for this particular exercise. And that data is my data. It is loaded in the form of a data frame, which is data.frame. And then we are reading a CSV file or comma separated value file stated as brca final2.csv. I hope it makes it quite obvious. The name of the file gives you the notion that it is a comma separated value file. The separation is a comma, quote unquote. And then note that in between square brackets, I have decided to remove the observation number 8, because that corresponded to a particular year for which we did not really have any data, so we decided to remove that. So now that we have had this particular data set, the first step is to read the data and do some transformations before we launch into graphics. So this is what I refer to as preparatory step 1. We read the data and do some transformations. In doing the transformations, we have my data W, and then I have again talked about we have taken in the brca final2.csv, use a separator comma. We have kept the header to be true, which means that the column headers will be retained, and if there are strings, or if there are value points that are not available, then they are kept as NA or missing values. And we have selected the first 16 observations. So it's very simple. You can practice some printing the names of the data set and then print the length of the data set to just check that things have really worked out. In the preparatory step 2, we are going to convert the data from wide to long. Now this is very important if you're dealing with what is known as a longitudinal data. In this particular case, we are dealing with a longitudinal data, and therefore we start with a data which is in wide format. That is, each of these years are presented in the form of single columns, and we have then converted that data into a longitudinal data format. So you see that we have got in INC 96, INC 97, and so on till INC 07, which is which stands for age adjusted incidence rate as calculated for the year 2007, and we have named the variable as incidence, and we have converted the data from a wide to a long direction. So you've got repeated measures of those data sets. The first graphic that I'm going to show you here will show you how you can add a bar plot, and then you can style the bar plot to some extent. So this is where we show that you can actually add a bar plot and style the dataset or style the bar plot. First, take a look at the code that we're going to use for this particular purpose. We are going to use the R's base built-in graphics engine that are very, very simple. So you really do not have to call any other package for running these exercises. Why is a bar plot used? A bar plot is used in order to plot categorical variables or discrete variables that have got their own levels or categories. So each of these categories will be labeled either in the form of percentages or in the form of their raw counts. There are a number of different ways in which you can plot a bar plot. In this particular case, because we know the numbers against each of these categories, in this particular case, the number, or in this particular case, we're going to take a look at the incidence and HRT usage. That is, what were the percentages of hormone replacement therapy usage? When did it peak in these countries? We are going to use that variable for each of these variables. So we'll have the year of peak HRT usage, and we shall see that what was the percentages of their usage. So we say bar plot, then I actually conduct a table. So you just cannot put bar plot and then a variable name. That's not going to work. You have to convert that into a table. Sometimes it helps if you use a function called summary and then summarize that particular variable. In order to put a header, which is a stylistic part, to that graph, you will use the option main, and then in this particular case we have decided that the main or the title should read as years of peak HRT use. Xlab basically stands for the label of the x-axis. So we say x-axis is year. Ylab stands for the label for the y-axis, and that stands for the number of countries that we have that have reached the peak HRT usage in that particular year. So in this particular year, for example, you can see that in the year 2001, most of the countries that were present in this particular data set had reached this case. We also have another option here, which is called ylim, which is labeled as 0 to 8, because the ylim is a very useful option when you specify a bar plot, because that tells you that what is the limit of the numbers, that is 0 to 8 in this particular case. So there were 8 countries at the most and no countries at the least. And col basically tells you about a color specification, and we'll see how we can specify colors in a bar plot or in any plot in R. In this particular case, we decided to choose our color of the bars to be black colored. Another example, which is quite important, is when we start talking about aggregated data. Now, in case of aggregated data, what we do is this, that we have some data sets in which we have decided that, okay, we are going to create a variable that will tell us in one sense as to say average breast cancer incidence rates. So rather than using categories and percentages or numbers of those categories, we now say, okay, we are going to go and take a look at if we could aggregate a mean or a median, for instance, for each of these year bands, then whether we can do that. It turns out that yes, it is quite possible to do it. It's very simple. Instead of using only counts of the countries, this time we have selected, okay, what would be the average breast cancer rate for the 16 countries? And here you can see that that can be put into in the format of a bar plot. In the next example, we're going to take a look at a continuous variable. And for continuous variable, the traditional presentation is in the form of what is known as a histogram. So if we are dealing with a continuous variable, then we do a histogram. If we deal with a categorical variable, we construct bar plots. And with histogram, I'm going to introduce you to a new thing. Take a look at this. In a histogram, and in this particular case, I have given you histogram with a probability density plot. Let me explain this slowly. Now, a histogram is used if you use a continuous variable, and what the histogram then does is that for each of these different values that you get for that particular variable, the histogram actually plots either a probability density or a percentage, etc. Or even sometimes the raw count for that matter. But the histogram gives you a rather interesting perspective as to the distribution or probability distribution of that particular variable. The function that you should use in order to draw histograms in R is the function called hist, H-I-S-T. And then note the biggest difference between a histogram and a bar plot. In a bar plot, you have to construct a table or you have to give an aggregate data to the program. In this particular case, you can actually take a variable directly from the data set and you can put it in. For example, we just wanted to plot a histogram for a continuously distributed variable, which is INCO1, which stood for incidence rate for the year 2001. And this was a continuous variable directly referenced from the data set. And then we had decided to draw a histogram out of that. There are a few options that are very important. For example, in a histogram, you need to give a break, which means that in how many different bars or in how many different sections or how many different divisions you're going to break this particular data set's distribution. I could have asked to plot for each of these 10 divisions their frequencies, but I decided that I'm not going to use frequencies. I'm going to use the probability density because I'm interested to also take a look at the density plot. So I said FREQ or frequency and I set it to false. As before, the title is given by the main, which is histogram of the breast cancer incidence in 2001 in 16 countries. I have used YLab, which is a probability density, and then I have used XLab or XLab, in which I have labeled the x-axis, and I told them that okay, this is incidence in 2001, so that we know what were those incidence rates and how were they divided in the 10 individual groups. After I had drawn the histogram, you note that I have issued another rather high-level plotting command, which is lines, which is about the density function that I have decided to draw on this particular histogram. So I have taken the histogram, and then on the top of the histogram, I have decided to draw a probability density based on the lines that will come out of this. And I have decided to put a color, which is a red color. In my previous histogram, I could have specified another color for the bars and a different color for my line, for the lines histograms. So lines function is the one that will enable you to draw a particular line on a plot. Very, very important. Next, we're going to see how we can draw bivariate box plots. Now, it is very useful if you know how to draw a univariate box plot. In a univariate box plot, it is very interesting because you can just issue a command of a box plot and it's going to draw you one. But with a bivariate box plot, it becomes quite interesting because you will now be able to draw box plots which are which will be in which you can actually plot two variables together. So let's take a look at this and see how we can draw a particular bivariate box plot. Here, the idea is this, that in order to do this, I have divided the age into several groups. And basically what I have done is this, that I have divided the age into I've converted the age into a binary variable. And that binary variable is drawn on the basis of the fact that if the age group was done at at ages where it was 45 to 69 or 50 to 64, 50 to 69, 50 to 74, which means that if the age in which in these countries the government started screening women using screening mammography were done at the ages of 45 years or above, then that would be 1, or assigned a value of 1, in which in this particular case R thought it would be assigned a value of true. And if they were done at the age 45 years of or younger, then that would be assigned a value of false, which means if false, then younger age in which you have this, otherwise true. And what we would like to do then is that we would like to plot the incidence rate of breast cancer in the year 2003, which is roughly 2 years after there was a widespread decline in hormone replacement therapy. And we just wanted to see whether age at which breast cancer was screened would make a difference. In this particular case, you see that it did not make a difference. And you can see that there was a very wide spread for for the age group in which there were older age women were screened versus younger age women were screened. And you can see that there is this little box. But now the point that you need to note here is this, that for bivariate box plots, you have to give the name of the continuous variable first, and then the tilde, and then you have to put the categorical variable next. Continuing on with bivariate plots, let's start and take a look at the drawing how we can draw a scatter plot with a regression line. Again, it is very simple as that. You just put the continuous variables, two continuous variables. For example, in this particular example, we have decided to draw incidence rate of breast cancer in the year 2002 and the peak HRT use percentages, which we treated as a continuous variable, and then we decided to just put it into in the form of a graph. See how easy it is to construct a graph. R almost intuitively knows what kind of a variable you are dealing with, and accordingly it plots the graph. In the previous example, you saw that when you gave a command that you wanted to plot a continuous variable with a categorical variable, R immediately knew what it was supposed to do and gave you a box plot or a bivariate box plot. In this particular situation, R knows that you are actually asking for a scatter plot, so R is going to give you a scatter plot. It's just that simple as that. And then you can use the line in order to put the regression line. But note, in order to put a regression line, you will have to tell R that you are going to run a regression between where you're going to regress the incidence on the peak HRT use percentage, which means that you have to regress the incidence rates for 2002 on the HRT use percentages, and R will automatically then construct the best fit line and put it onto the plot. We will later see that you can actually change colors of this line as well. So let's take a look at how we can change colors in our graphs. Here is an example where we have decided to use a rainbow coloring graph. So what we have done, we have again taken the same thing, that is, we have actually decided to do an aggregate percentages, that is the average of the breast cancer rates in the years in which HRT rates kind of peaked, and then we have then decided to use the aggregated bar plot values. But note here that we have got like about 7 different bars. So it is not a really intuitive thing to do, but you could probably just use a color option such as black or red or blue. But see what we have done here. Instead of only confining ourselves to one monochrome like a black or white or green or red or blue, whatever, we decided to actually paint each of these bars in different colors. So we chose rainbow, and we specified that we would like to have 7 colors in this. Well, according to the conventional notions of rainbow, we would like to see like 7 colors, but you can have even more colors that you can splash here. You can actually experiment with this. The next thing that I'd like to put here is this, that R gives you much more fine tunes in terms of how you want to see your graphs using a command which is known as par. I encourage you to look up par because par is actually quite a broad topic, a broad-based topic in our graphics, and we have introduced par before, but this time I'm going to give you a demonstration of how you can use R. So in this particular case, we have decided to use par, but we have decided to use and break the canvas into 2 columns. Therefore, you see that par within parentheses mf row equals C1, 2. Let me explain this. The word par tells you that you're actually going to use some parameters in order to work on the canvas. The word mf row indicates that you are going to fill it row-wise. So which means that you will first fill the first row and then you're going to fill the second row. Of course, in this particular case, that does not make much of a difference because you've got only 1 row and 2 columns. So you say next, you specify the rows and the columns. So you start with the rows and the columns. So C1, 2 tells you that there is only 1 row and 2 columns. Then you issue the command about plotting. Look here, what we are going to do is this, that we are going to put 2 plots side by side. So we specify the first plot, which is incidence in 1996 against peak HRT use percentages, the usual bells and whistles about the title, the labeling of the X, the labeling of the Y works. Then we have put a regression line, and then in the next we wanted to see incidence rates in 2002 against peak HRT use percent and put the regression line. So if you take a look at this, this is the output that you get to see. See, in one canvas there are two sub canvases in which we have able to put our graphs. So this gives you a brief overview of the different kinds of things that you can do using a real world data in order to produce some beautiful nifty graphs in R. So in summary, we learned how to plot different types of graphs in R. Remember that in R, your starting point of graphing is that you should identify the data and you should transform the data properly so that you know exactly what you're doing with this. We selected sort of a tricky example of taking a wide formatted data and converted that into long. And then you should know what kind of data that you're going to use for whatever analytical work. For example, for categorical variables, you'll be using a box plot. For continuous variables, histograms, etc., etc. You can use color spaces to actually color your graphs in many different ways. And if you want to change the environment of the graph, that is, break the canvas or do some other work, remember to use the bar option.
Now that you had some introduction about how we can draw graphs in R, you learned that you can invoke the R canvas, then you can partition the R canvas into a number of different segments and sectors where you can draw graphs. You learned how you can draw different kinds of graphs, that is, different kinds of variables, putting them together. Single variables, you can draw bar plots, you can draw histograms, you can draw scatter plots, you can actually draw lines on scatter plots and histograms. This should give you a fair enough grounding to get exploring the more advanced graphical capabilities that R can offer you. We just touched the very surface and very basics of some things that R can do. I leave you to explore in depth more things. In the next ones, we're going to pick up on topics such as the CRAN task view, in which you will learn how you can use R the other way around. Like you have a task, and then you start from the task and start looking at what are the packages that you can use to play with R.